Hello everyone, welcome to this YouTube channel. This is teacher Stephen Omondi Okech, an experienced teacher of chemistry. Today we are going to discuss and introduce this topic called organic chemistry. The organic chemistry 2. The organic chemistry 2 mostly deals with the alkanols and alkanoic acids. Organic chemistry is a very examinable topic, and it will not miss in any of your exams as we introduce it. Even at KCSE level, it will never miss, maybe in paper 2 or paper 1. And also paper 3, it is also being tested in paper 3, question 3. So I want you to gain the knowledge, work with me as I explain all the concepts needed for this topic. And if you have any concern or any question, kindly ask through the comment section. I'll be able to answer you. And maybe if you need a further explanation, I'll be able to do as you request. Welcome. And now let's go to the next slide. So the organic chemistry 2, alkanols and alkanoic acids. So we are going to begin with the alkanols. The alkanols are also known as the alcohols. The common alcohols you see around, maybe you've seen people taking alcohol. The alcohol they take, there is this functional group called the hydroxyl. The hydroxyl is a functional group in an alcohol that gives it a site for reaction, to mean the alkanols are reactive compounds. So the alkanols are derived from the organic compounds alkanes. For example, in Form 3, we discussed about the alkanes, and we said the first member of alkanes is methane. So from those members of alkanes is where now we derived the alkanols. Where, for example, we can take, for instance, the first member of alkane is methane. And now we will derive from that alkane, we'll derive the first member of alkanol or alcohol, which is now methanol. And the second member of the alkane is ethane. So you realize that from the alkanes, we get the alkanols, methane, methanols, ethane, ethanol, and you will be able to learn as we proceed. So we will remove, or for us to derive the alkanols from alkanes, one hydrogen from the alkanes will be replaced by the functional group, which is hydroxyl, and to make it now an alkanol or alcohol. That is, an hydrogen atom from alkane is replaced with the hydroxyl group. The alkanols have hydroxyl, which is the functional group of the series. The functional group determines the chemical properties of the alkanols, where I've said it gives the alkanols the site for what? For the reaction. There is where the reaction takes place. Just the way you discussed in alkenes, you said that the alkenes, the double bond in alkenes is the site for the reaction for that compound. Also, you talked about the alkynes. The alkynes, we know that the double bond, the triple bond, the triple bond is now the site for the reaction. Now in alkanols, now the site for the reaction is where the alkanol is attached to, the carbon to which the alkanol, the hydroxyl, the hydroxyl is attached to. The carbon to which the hydroxyl is attached to give the site for the reaction. We also say that the alkanols are saturated hydrocarbons. What did we say about the saturated hydrocarbons? The saturated hydrocarbons is an hydrocarbon in which the carbon to carbon atom is linked by a single covalent bond. For example, here, carbon to carbon is linked with a single covalent bond. So that is how we define the saturated hydrocarbons. So saturated hydrocarbon compounds are organic hydrocarbon compounds with or in which the carbon to carbon atom is linked by a single covalent bond. Let us come to now the general formula and the nomenclature of the alkanols. The general formula for the alkanols is ROH. ROH, where the R is the alkyl group, and the alkyl group is just from the alkanes, where one hydrogen atom has been replaced or removed. When an hydrogen atom has been removed or replaced, rather than or removed, from the parent name, that is maybe methane. If we remove one carbon atom from methane, if we remove one carbon atom, because here we know that not carbon atom, but hydrogen atom, sorry. Yeah, sorry. If we remove the one hydrogen atom from this methane, we'll have CH3. So this CH3 is now the alkyl, which is now the methyl. You should be able to know that. So this R is the what? Is the alkyl group. Then this OH is now the hydroxyl, the function group of the alcohols. You should be able to know that. So the R is an alkyl group. The alkyl group is the name given to the group of atoms remaining when one of the hydrogen atom of the alkane is removed. For example, we have methane. Methane has 4 hydrogen atoms. When we remove one hydrogen atom, we'll now have 3. So this will have CH3. So this CH3 is now the alkyl group, which is called the methyl. We have also methane. When we remove one hydrogen atom here there are 6. We remove, there will be 5. So from there, we'll be able to get the ethyl group. When we have the propane, which is C3H8. So when we remove one hydrogen here, there will be 7. So we realize that one hydrogen atom shall have been removed for it to form the alkyl group, which is now the propyl. Thank you very much. The methyl and ethyl are example of the alkyl group, which is now given or represented by the letter R. To get the number of carbon or hydrogen atoms, they will represent the general formula with R. We can also use the general formula, which is this one, where we have CN H2N plus 1. Then we add the hydroxyl group. So N is now just the number of hydrogen atom, and N can be any whole number. That is from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in that order. So in alkanes, we said that the general formula for the alkanes was C N H 2 N plus 2. So you realize that in this case, we add 1. Why do we add 1? Because these 2N plus 1, those are now the number of hydrogen atoms. Now here we see that we add 1, and here we added 2. Here, the reason why we add 1, because 1 hydrogen from the alkane has been replaced by the hydroxyl group, because the carbon should have 4 bonds, which we will be also will able to discuss into details. So here we add 1 because 1 hydrogen atom from the alkane has been replaced by the hydroxyl group. So we have the nomenclature. The nomenclature is just the naming, the system naming, or the UPAC naming of the alkanols. The alkanols are named by replacing the letter E of the corresponding alkane with the suffix OL. So we replace E with OL. For example, here we have methane. So we'll replace this E with OL to form methanol. In ethane, also we'll replace this E to form ethanol. We replace E with OL. Then propane, also we replace this one. This E, we replace it with OL to form the propanol. Butane, the same, we replace the E with the OL to form butanol. And the pentane, also we can replace E with OL to form the ethanol, the pentanol, sorry. We have the rules for giving or assigning the alkanols the UPAC name. 1, the first rule, identify the longest carbon chain containing the hydroxyl group, which gives now the parent name. So you identify the carbon chain, the longest carbon chain with the hydroxyl group. So realize that this is the continuous chain. And this chain, there is a carbon attached to hydroxyl. So this one, to identify the parent name, you now count the number of carbon atom. And here we'll have 1, 2, 3, 4, 5. No, we'll have 1, 2, 3, 4. I mean, not 5. 1, 2, 3, 4. So 4 from the alkanes is butane. But in alcohols, we know that it will be butanol. So this one will give us the parent name, which is now butane. The butane, which is this one. So you first of all, you identify the carbon chain, the continuous carbon chain with the hydroxyl group attached to. Then from there, number the longest carbon chain such that the carbon to which the hydroxyl group is attached to has the lowest number possible. So like if we begin from this side, if we say that is 1, 2, 3, 4, you realize that if we begin from this side, the carbon to which the hydroxyl group is attached to will be at the 4th carbon. But if we begin from this side, it will be on the 1st carbon atom. So we will begin from where the carbon atom is attached to. For example, we begin from this side, it should give us the lowest number possible, because if you compare 1 and 4, you realize that 1 is lower than 4. So we begin from this side, count 1, 2, 3, 4. Like that, then we go to the next one. Indicate the position of the hydroxyl group in the name. E.g., we said it is from this side 1, 2, 3, 4. So it will be butan 1 all. So this one shows the position of the hydroxyl group. Check this one again. We can't count from this side. If we count from this side, it will be 1, 2, 3. So to be the carbon to which hydroxyl is 3. But if we start from this side, it is 1, 2. So 2 is lower than 3. So we begin from this side. That is 1, 2, 3, 4. So now the position of the carbon to which the hydroxyl group is attached to is carbon number 2. So now when we are naming, the parent name, we first identify the parent name, which is butan, because of 4 carbon atoms. So butan 2 all, where the 2 is now the position of the hydroxyl, the position of the carbon to which the hydroxyl group is attached to. Locate the position, that is rule number 3. Locate the position of the other subsequent groups using numbers that correspond to their position along the carbon chain. So you begin from, you number from the carbon near the carbon to which the hydroxyl is attached to. So we begin from this side, that is 1, 2, 3, 4. Even if we begin from this side, it will be 1, 2, 3, 4. You can either begin from this side or you begin from this side. There is no harm, because if you begin from this one also, it will be 1, 2, 3, 4. Begin from this one also, 1, 2, 3, 4. But if you begin from this side, it will be 1, 2, 3. So to mean the hydroxyl is in group carbon number 3, which is now wrong. Now, if you check this one, we have a substituent. If you begin from this side, 1, 2, 3, 4, there is a substituent, which means there is a branch. This branch, this is an alkyl branch. This is now an alkyl group, because 1 carbon atom has been replaced by 1 bond. The bond is this one. The covalent bond has replaced 1 hydrogen atom from the alkane member, which is methane. So now from methane, being that 1 hydrogen atom has been replaced by the covalent bond here, it is now the methyl. So when you are naming, you begin from the branch. The branch is at the 2nd carbon atom. So that is 2 for the position of the carbon to which the branch is attached to, the alkyl group is attached to. So we'll have 2 methyl, then the parent name we have 1, 2, 3, 4. 4 carbon atoms, that is butan 2 alkanol or the hydroxyl group is attached to the second carbon atom, which now gives it 2-ol. So it is 2-methyl butane 2-ol. So you begin from the position of the, when you're naming that, you begin with the position of the branch. Then you go to the parent name, then position of the hydroxyl. Then you finish with the ol. That is, let's see these ones. So the names, molecular formula, and the structure of some alkanols. So the methanol, we said that it comes from the word the methane. So one hydrogen has been replaced by the hydroxyl group, and that gives you the molecular formula. So that is the molecular formula. When you are now drawing the structure, the structural formula now will look like this, because carbon must have the 4 covalent bonds. If you count, this is 1, 2, 3, 4, like that, for which the skeleton also will look like this one. One carbon atom attached to so we have carbon there. Then we can have hydrogen and hydrogen, hydrogen, hydrogen. Then we have the the ethanol, where the one hydrogen has been replaced by the hydroxyl group, and now give us this one. When we are drawing now, we have 2 carbon atoms, that is C, 2 carbon, 2 carbon. And this one, we have the functional group, the hydroxyl. Then we have another bond there. Then there are hydrogen bonds, not hydrogen bonds, but the covalent bonds. So those one, we have also another one like that. So the 1, 2, 3, 4. So hydrogen, 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 just like that. That is how you will be able to draw even the rest. So pentanol, let's check at the pentanol here. The pentanol also, one hydrogen has been replaced by, because there were to be 12 from methane, because we know that 5 times 2 plus 2 is 12, but here they are 11, because one has been replaced by the hydroxyl group. Now the molecular formula is now this one, but now we can condense this one. You can count how many CH2 do we have? We have 1, 2, 3, 4. 4 CH2s. So we can now write CH3 into CH2 into 4. So there are 4 CH2s. And you can now draw the structural formula. For the skeletal, we have 1, 2, 3 skeleton. For this, you can draw 1, 2, 3. Sorry, let me draw it well. 1, 2, 3, 4, 5. It should be 5. That is 1, 2, 3, 4, 5. Then We'll have OH, then like that. So there should be 1, 2, 3, 5, like that. That is how we draw the skeletal formula. I want us to stop from there. Then in our next lesson, we'll be able to go about the isomerism of the alkanols. That is that. Thank you. Subscribe and follow me for more video. And give any comment, ask any question that maybe you will wish to, you will wish to ask, so that at least we work together. Bye, subscribe, and have a nice time as you prepare for more videos on this topic.